thinking about formative assessment in mathematics. And what I wanted to do today was to go deeper into the idea of learning goals and success criteria. We spent quite a lot of time focused on that in our session, but the idea of the webinars is that we can think about them specifically in relation to subject matter content. So if we can have the next slide, Paul, what I was hoping that you would get out of this is a deeper understanding of the role of disciplinary knowledge in establishing learning goals and success criteria, because that was certainly one of the things that I did mention, and where the field is going much more thinking about the context of the discipline and how it affects learning and obviously assessment for learning. And then the second one was to be thinking about progressions and how progressions are important for learning goals and success criteria. And then the final one was to apply your understanding to evaluating learning goals and success criteria. I think I have a first and second grade one here, but I didn't put a kindergarten one, but I certainly have a first grade, so that's pretty close to you. And then the success criteria, so after this webinar, I want you to be able to explain to your husband what the disciplinary considerations for learning goals and success criteria are, to describe how progressions, the idea of a progression across standards, can support learning goals and success criteria, and then from some examples to identify stronger and weaker goals and explain the reasons for your judgment. Have you taught other grade levels other than kindergarten, Anna? Anna, are you still there? Do we have a chat box, Paul? Anna,
yeah, there she is.
There you are.
She got muted somehow.
So have you taught any other grade levels, or have you always been a kindergarten teacher?
No, I've always been a kindergarten teacher.
Well, we'll have to try and customize it a little bit for kindergarten. Okay, so next slide then, please, Paul.
Okay, I'm trying. There we go.
So just to remind you of what we talked about in the session, that formative assessment is the term we use to describe assessment where the emphasis is on informing learning. It's not measuring it or summing it up like the end of the year assessments or any kind of interim or end of unit assessment. So it's really about ongoing, Paul, if you can click please, ongoing assessment focusing on learning as it's taking place. So remind you, not at the end of learning, but during learning. And we'll talk about that a little bit more when we get into some of the ideas of the disciplinary content. And so what we discussed in the session, and this is just a reminder, the purpose is to move learning forward from its current status. So wherever kids are, the edge of that learning, we're going to work from that in the learning zone, in their learning zone, and advance that learning to meet the goal of the lesson. So that was just a little reminder. And then in the session, I did share some quotes that I got from teachers who spent time on formative assessment, really learning how to implement it well in their classrooms. And this was after about a year. One teacher wrote, "I used to think that formative assessment was just checking for understanding, but now I think it's an integral part of a lesson plan and essential to reaching learning goals." So I think that really underscores the idea of the integral part of formative assessment to ongoing teaching and learning. And it's not a check for understanding, it's much more about what are the partial understandings, where are students right now in their mathematical thinking, so that we can continue to advance that thinking and meet the goal of the lesson to reach those learning goals. So, another reminder that there are 3 guiding questions to the formative assessment process. First of all, where am I going? And we're still going to maintain our emphasis on that throughout this webinar, as we did in the first session. Where am I going? Where am I now? And then where to next? So the idea being here that where am I going is the learning goals and the success criteria. What are my kids learning? Students need to know what they're learning. And, you know, your children in kindergarten, as I'm sure you're quite aware, can really take on the idea of learning goals and success criteria, even as young as kindergarten. And the whole point of formative assessment, once again, if you can click Paul, there's another part to this slide, is to close the gap. So where the children begin at the beginning of your math lesson and where you want them to be at the end. So formative assessment helps you figure out where students are in their learning while they're learning, so you can make those adjustments and keep learning on track and then plan for the next lesson. So those are just reminders of where we are. And of course, the learning goals and the success criteria are key to the whole process of formative assessment, as you can see in this cycle here. And we didn't get a chance to talk much about the building blocks in our session, and we'll be able to address that a little bit more in the context of specifically focused on mathematics. So determining learning goals and developing success criteria. So we're still in the red zone. Okay, do you have any questions on it at this point? Or that was just a sort of quick review from our earlier session. Do you have any questions or comments?
No.
You got that? Okay, good. So let's stay in here in this red zone and dive a bit deeper into learning goals and success criteria. So remember, the question teachers need to be able to answer is, what are my students learning? Not what they're doing, but what they're learning as a result of the tasks and the activities I've planned for them. And then the second part of this is, how will I know if they've learned it? So it's not just a case of, well, here's the goal, this is what I want them to learn today, or learn within the next 3 days. But it's also about those indicators. What will the children be able to say, do, make, or write that lets me know that they're on the way to meeting that goal, or that they've met the goal? And so those were the critical components we focused on in the larger session in the meeting. So I know what my students are learning, and I'll know if they've learned it. And of course, the second part to all of this is that the students know. And I love this quote from Mary Alice White. And she talks about when students come to school, they're really like a sailing ship on an unknown sea to an unknown destination. And I think this quote is very telling. She says, a child only knows he's going to school. Very quickly, the daily life on board ship becomes all important. The daily chores, the demands, the inspections become the reality, not the voyage, nor the destination. And I think this sits very nicely with the idea of formative assessment, because we want students to know which sea they're on, which voyage they're on, and what is the destination of going on that voyage, going to culminate in. So I didn't share this at the meeting, but I think it really fits with what we're trying to say today, because it's not just the teachers who need to know where they're going and how they'll know if they've got there, but the students do. And we want school not to be a set of busyness, you know, the chores, I'm writing my name on a piece of paper, I'm doing the activity, I'm doing a quiz, I'm getting a grade. It's much more about, what am I learning? why am I learning it, and what's this voyage to all this learning going to be? So I hope you like that quote, because I think it's particularly telling. And so that then leads us to the students part of this, which, as I said, we'll focus on much more in the third session. But the students also knowing, I know what I'm supposed to be learning, and I'll know how I've learned it. So next slide, please, Paul. Yeah, I know what I'm supposed to be learning, and I'll know how I'll know if I've learned it. And of course, with your students, Anna, that's going to be very much the case of getting it right in the language of your students. You know, as we said, that how you think about learning goals for middle, upper elementary, middle, and high school is going to be different from how you communicate them to a kindergartner. But nonetheless, they can handle it, as I'm sure you are well aware. And so this gets us into the idea of the teacher knowledge for formative assessment and the whole notion of disciplinary knowledge. And what I've put here, that this disciplinary knowledge consists of understanding or recognizing what knowledge kids need in a discipline. What are the conceptual understandings that they need to develop, those key concepts? The analytical practices, and in mathematics, if you look at, and I don't know if your school follows the Common Core standards.
Yes, they do.
You do, yeah, that's good then. Because the Common Core has these mathematical practices which really are about analytical practices in mathematics, and then what particular skills do students need to be acquiring. So all of that is the background knowledge that teachers need in order to both teach and assess effectively to get students where we ultimately want them to be at the end of high school. And so you start right at the beginning with these students, helping them build the knowledge they need, the conceptual understandings they need in kindergarten, the analytical practices, and the skills. So next slide, please. So I'm going to ask our mathematical experts to talk to these slides, because these are the kinds of things that when you're thinking about planning your math learning for your students, and also part of planning the math learning is thinking about, well, how are you going to get evidence of that learning while the students are engaged in it? Then these are some of the considerations to bear in mind. So let's just hear from our math experts, and we'll start and see if you have questions or comments on them.
Well, I'll jump in first, and then Fran, I'm sure can jump in with possibly specific examples. But I will say one of the shifts that we've seen with the new standards is increased focus on conceptual understanding versus just procedural skills. And it's not that procedural skills aren't important, but it's that the conceptual understanding is a piece that we realize over time that if our students don't have that, then those procedural skills go away pretty quickly. So they have to have those conceptual hooks to hang the procedures on, or they don't retain that, or they get that all mixed up. You know, an important way of us being able to assess whether or not they have that understanding is by them really engaging in conversation, so that we can listen to what they're saying and be able to gain that knowledge on where they're at. So let me with that pitch it to Fran for any specific example toward elementary.
We can't hear you, Fran. I can see. Got you. Yeah, we got you now.
Did you mute me, Paul?
I did not.
Oh, no, he's not going to answer. Okay, I'm unmuted. the whole idea about what Dave said is, hooking procedural ideas onto already solid understanding is really a big difference in the Common Core. We're not just memorizing and checking off a box and moving on. So you can apply that to facts. You can apply that to place value concepts. We have to understand things deeply so kids know when they're doing something, if it's right or wrong, if it makes sense, if they're going to get a reasonable answer, if their answer is unreasonable. And you can't just do that if you're only procedural. So the idea of conceptual understanding is really, really important. Is there more to this slide?
Yes.
Oh, good. And Dave talked about that, this idea of connection among ideas. Anna, you teach kindergarten. We did some research with some first graders, and this goes back to what we were talking about with key words, Margaret, last week.
Yeah.
Where kiddos were given a problem. It was about balloons. I have 9 balloons. I want to have 12. How many more balloons do I need? And most of the time, teachers will tell kiddos to subtract. How many more means to subtract? And in fact, all these first graders that we interviewed, there were like 50 of them, they all added up because they understood what was going on in the problem, and they added up from 9 to 12 and could tell you 3. So I think that that's evidence of a conceptual understanding, not just a procedure that they learned.
Mm-hmm. Nice. Yeah.
And then, of course, a big thing, and Dave, you can pop in. I lost you, Dave. I can't see you anymore. But the idea that we want students to be able to communicate their thinking, why the choices they're making, what they're doing, why they're doing it, is it reasonable? And that starts in kindergarten. We want kids to start to express themselves as best they can.
So I'll jump back in and
Okay.
communicating their thinking. Am I back now?
You are.
I don't know. I dropped out for a minute and I'm not quite sure why. But communicating thinking is something that I think I have observed students at all grade levels are struggling with. And
Mm-hmm.
And I think part of the reason is because I have to go back and say, how many opportunities do students have in class to be able to communicate their thinking? Because if the only time we ask them to communicate thinking is on some type of assessment, then it makes sense that they struggle with being able to do that.
Mm-hmm.
Mm-hmm.
And of course, that's key to formative assessment, as you said, Dave. Listening to children's ideas, interpreting how they're making sense of mathematics, all comes from this communication, justification, explanation, and understanding their reasoning. I think there might be one more bullet here. Yes, engaging them in the mathematical practices. Yeah,
Which that goes with all the bullets before that. Is Anna there? I don't see her anymore. I'm wondering.
Yes, I'm still here.
Oh, how does this play out in your classroom? What are you trying to do with your little kindergartners?
Since they're only 5 years old, it's kind of, sometimes I find it difficult to do the assessment
Mm-hmm.
because sometimes, they get distracted very easily.
Mm-hmm.
So what I do is that I provide different hands-on activities with them, and just have them in groups, so I can concentrate on one group and then move around the classroom in order for me to able to see where they are. But I definitely feel that this is very important.
And are they getting better? Are you seeing evidence of them getting better about explaining their thinking, whether like if they're using a model or if they're using manipulatives? Are they able to try to attempt an explanation on why they might have solved something, like, for instance, that balloon problem? If they had we'll make the number smaller. 4 balloons and they want 6 balloons. How many more? That's a tough problem for a kindergartner. But do you think they could show that and explain that?
Yes, definitely they can.
Okay, great.
That's really good. And
Actually, if I might just lend one more thought, Anna, Fran and I both know a fantastic K1 teacher who retired recently. And one of the quotes that I steal from her and use quite often is she said, I got a chance to go be in her classroom for a while, and she said, today we're working on this math practice standard, construct viable arguments and critique the reasoning of others. And she said, for my kids and for your kinder students, constructing viable arguments means that they can explain their thinking and explain what they're doing, because they'll never be able to construct an argument if they can't explain what they're doing. And she went on to explain that critiquing the reasoning of others, grade appropriate at kinder is, can they listen to what somebody said and be able to revoice it in their own words? Because if they can't process and revoice it, they'll never be able to critique.
Correct.
That's really helpful, Dave. Really helpful. I like that a lot. Yeah, this is why we have the subject matter folks on, Anna, because they can bring all this depth of expertise to this. But what you said about, sitting with them and focusing on the group, I mean, I think it's great you're giving them hands-on activities, and that, when you're asking them about their activities for the explanations and their justifications, I mean, that's essentially formative assessment, what you're doing right there, getting an insight into how they're thinking about the mathematical ideas that you're trying to engage them with. So it sounds like you're doing just the right thing there, which is great.
Thank you.
But I think Fran and Dave, especially for me, just really emphasize the importance of those explanations in kindergarten.
Yes.
And helping kids understand what an explanation is.
Right.
Because so often we throw these out, write a summary, do an explanation, without any kind of teaching as to what an explanation really is. So, but you've got the structure and the opportunities there, Anna, with the way you've actually structured your entire lesson and the learning opportunities. So that's great. So, when you're thinking about, I don't know if we can make these slides available, Paul, but this would be good things for you to be thinking about, Anna, when you're lesson planning, and also thinking about what's the formative assessment opportunity. How do I get to see if they're understanding these key ideas? How can I see if they are making connections? Are they able to explain these connections? Are they able to explain their mathematical ideas? So those are some core disciplinary considerations that obviously as a kindergarten teacher you take into account. And they become the grounding for formative assessment. So next slide, please, Paul. Wait, before we start, I'm droning on. Anna, do you have any questions at this point? Do jump in, otherwise we're just going to be talking at you.
Okay, no, everything seems really clear.
Good. Okay, well, feel free to jump in and stop us. And really the reason, and I mentioned this in the session, I know, but the whole point of the way the standards have been written and developed is so that there's connection across the standards. So, as I said in the past, we've tended to, this mile wide and inch deep mathematics curriculum is really just centered on, I do this little skill, and then I do this skill, and then I do this skill. And it doesn't really amount to anything substantive in terms of understanding mathematical ideas. So this is what we're really trying to get away from. And I think both Fran and Dave have said that, moving much more to thinking about conceptual understanding, and then I like the way you said that, Fran and Dave, that you hook the procedural competencies onto this understanding so that kids can remember it, which is nice. So next slide. So we don't want this atomistic discrete skills anymore. That's not helping us. But next slide, please, Paul. But what we do want is this idea of a connected pathway between the standards. So if you think about it from the point of formative assessment, I don't know if you recall the assessment system. I showed you the cone with the smallest grain size being formative assessment. So are we able to see, when we're planning the learning goals, are children actually focus on these incremental changes in their thinking? So I use this as the idea of a stepping stone. So if you imagine the first one, the stepping stone nearest to you is the end of one standard. Thanks, Paul. I was moving my cursor and it wasn't working. And then the stepping stone right at the end of the pathway. And along the way, it's like the voyage. This is the voyage to the destination. And so there are these little but substantive learning goals that we have for children, but they're all connected because they take them on that journey towards the next standard. And it's at this grain size that we can do formative assessment. So if we think about what's something really important in kindergarten? Well, counting obviously is a big one, but counting and then being able to organize your count will be, one of the building blocks. Fran, you're going to help me out. Organizing your count, explaining why you organize your count in particular ways, and then figuring out other more efficient ways to count large quantities, like when they get to 100, rather than counting ones, what's a more efficient way to count in ones. So to me, Fran will correct my mathematics, but that's the idea of how you move along in these incremental steps, but it's all connected. So one bit builds on the next, builds on the next. That's the voyage to the journey. Fran, do you have anything to add to that? Or?
Well, I think when we get to the progression part, as you're starting to explain, we have a video we could show on counting and cardinality that is kindergarten's ballpark.
Excellent. That's perfect. Perfect. Okay, so next slide then, because it'd be good to get to the example. Yeah, and so this idea of a progression or a pathway, a learning pathway, and that what you're doing in lesson 1, however many class periods you want that to be, 1, 3, connects to what you do in lesson 2, then connects to what you do in lesson 3. And that's part of building that conceptual understanding. So it's all connected across from one standard to the next. Does that make sense, Anna, what we're saying here?
Yes, I understand what you're saying.
So maybe let's see if we get to an example fairly soon. And of course, so the idea is, these concepts, analytical practices and skills that we want students to be acquiring, they start, and here you are in your kindergarten with your little seeds, and you're growing, you're nurturing that seed so that it becomes a little plant, which as they move through their schooling becomes, you can think about this in 2 ways. You can think about this as the kindergarten year. So what are some of those early concepts, like Fran said, counting and cardinality? So what are those beginning points of counting and cardinality, and then how do they progress across the kindergarten year? So that by the end of kindergarten, they've met the standard, they're a lovely tree with all these beautiful leaves. You can think of it that way, and you can also think of it K-12. That, you start, and again, you're starting in the seed, but as they move through their K-12 schooling, those seeds that you've planted become nurtured and more sophisticated as the students progress through schooling. So the idea of this progression, that it's connected and that it leads to more sophistication in mathematical understanding, either over the course of your kindergarten year or as your kindergartners progress through school. And so it's this notion of progression that we really want to, I remember when I first became, actually it was a lab school at UCLA, I probably shouldn't even say this, but one of the things that I did walking around, I thought, well, you know, I want to look and see how progression is represented in mathematics. And you know, they were focusing on graphing, and I looked and there was no progression across the entire school that I could see. So that became a focus of conversation for us, you know, how are we building on conceptual understanding? So it's just one graphic, you know, for you to think about from your year. And maybe we can see this, Fran, when we get to the cardinality and the counting progression, so you can see it. Right. That's the idea. And so it's like a GPS, you know, your learning goal is, where am I going? I'm on this voyage. I know what the voyage is, and this is me keeping my kids on track till I get to that learning goal that's so important. So think of it as your GPS system. All right, so next slide.
Before we ever get to addition and subtraction,
Before
we tackle fractions and decimals, there's so much understanding that needs to take place. So here, I'll try to explain the progression of early number and counting. Well, before students come to us in kindergarten, they begin to see what numbers look like. I mean, literally. Check out these dice. Students know that there's 4, 2, 3, and 5, but they don't know that quantity. They're just simply calling out number names and matching them to what the things look like. They know that we have 3, 3, 5, and 4 on the yellow card. What they're doing is matching a number name to a visual pattern. This is a really big piece, but a lot of kids are able to do this before they come to us in kindergarten. This ability to recognize quantity without counting one-to-one is called subitizing. Some say sub, some say su. I just say it's magic. But here, if we were to show the number 4, a student might say 4. Yes, they know the number name, but if you ask them to prove it, they might count them 1, 3, 9, 7. This is a perceptual subitizer. They cannot explain why it's 4. I think most of us are familiar with the conceptual subitizer that would say 4 because there's 2 and 2 more. In this early trajectory, we're talking about a perceptual subitizer. So as students are working on this idea of subitizing, they're simultaneously building their understanding of more and less. Let's take these two hands, for example. If we were to put some candy in each hand, and then we were to ask a student, you know, which one has more? I think most students are going to say the one on the right has more. And they're able to recognize this because they can visually see and compare the difference. They can't tell you exactly how many more, but that visual representation of more, well, that ties back to what they're doing with subitizing. The students don't need to count to compare the quantities. If we were to take some candies from the right hand, put them in the left hand to where they're equal or almost the same, now we have a need to count. So when students come to us in kindergarten, we now know that they have this idea of subitizing and more or less that they've been working on. So from there, we introduce rote counting. Rote counting, well, it's kind of like this. As students are learning the alphabet, they might say LMNOP and have no idea that there's actually letters embedded in there. Rote counting, same thing. Students are just working on that count sequence, the reciting of names. So an example of that would be as if we asked a student to count from 1 to 6. They might say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We said stop at 6, but you know what? They can't. They have no idea where 6 is in that count sequence. Well, in kindergarten, students should be working on that count sequence from 0 to 100, forwards and backwards. I think most students in kindergarten have had exposure to a hundreds chart or a 99 chart. But what about this one on the right? When the value increases, the numbers on the chart rise up. Now when we count up from 0, we don't go down, we actually go up. That might make more sense to kids. Something to think about. So as students are working on this idea of rote counting, we begin to introduce this idea of one-to-one correspondence. And to be honest, one-to-one correspondence, it's much more than simply tagging numbers to objects. Here's an example. If we ask a student to count 8 and place them in the bowl from a set, and they're able to do that, they're a producer of counting. They're able to do that one-to-one tagging to 8. Now, if you ask them how many were in the bowl, they don't know. They'd have to go back and recount them all over. A student that we'd ask how many didn't make it inside the bowl, well, they're a counter. They can count a finite set of a quantity. So for instance, there was 4 that couldn't make it. So we want to make sure that students are both counters and producers. And one way we can do that is by building this understanding of tagging, but not always with numbers. So here we have 6 bears, and we want to match each bear to a green present. This idea that's happening in one-to-one correspondence, it's really, really big, and we need to make sure that we devote enough time for our students to develop this understanding. So as students are working on rote counting and one-to-one correspondence, cardinality gradually makes its way into the conversation. What cardinality is when students are counting out a set of objects. The last number in that count sequence describes the quantity in the set. Students might count this pattern here of these pennies, but they might double count some. So now they use a counting strategy where they line them up and count from 1 to 8, and they know that they said 8 last, so that there's 8 in the count sequence. This was an example of a counter with the pennies, and on the bottom here with the rec and rec, we have a producer of 8. And they're able to tell you that it's 8 because of the last number. We then move on to hierarchical inclusion. Yeah, it's a really big word, but all that it means is that students understand that numbers are nested inside other numbers. So if we take that penny, for example, students would know that if you had 8 pennies, you must have 7 pennies. That numbers are nested inside the numbers. So if we ask students to put 7 inside this circle, do they need to count out 7 pennies, or do they just remove 1 and drag the set into the circle? The same idea with the rec and rec. Do students count out 7, or do they just know to remove 1 because 7 is nested within the 8? And at the final part of this progression of early numbering counting comes number conservation. The big idea here is that students understand that there's a decomposition of number. We might ask, are they the same? Students would say, yeah, we have the same number. But if we stretch out the blue row and ask which one has more, students might say the blue. This is at the heart of number conservation. It's about decomposition, that numbers can be broken apart, and that numbers, the whole, is made up from parts. So at the beginning, we talked about a perceptual subitizer. Well, here we have 3 sets of 4. Well, when students get to this piece in the number sense trajectory, they understand that 4 is made up from parts. So now when we show students these dots and we show them these yellow cards, they're able to see that 4 just isn't a name, it describes the parts of a whole. Now we're getting to that conceptual subitizing. There's a whole lot happening here. One thing to remember, the turtle won the race. Thanks for watching.
Let's continue the conversation on Twitter.
That's one of his daughters. The idea of learning your addition or subtraction facts is kind of the very narrow road we used to be on. And so kids would memorize a fact and maybe get it right or maybe not. And now, I know I taught first grade for a long time. We would always complain about number sense. Kids don't have number sense. Well, the counting and cardinality standards lay it all out on the line and kind of say, this is how we start. Kids have to understand all about these counting and cardinality principles in order to start to build number sense. And then what comes next, of course, is in kindergarten is adding, subtracting, and place value, being able to understand that numbers can be 10 and some more, or 2 10s and some more. So it's really, as Margaret was talking about, this massive progression that starts as a little baby seed and just keeps getting stronger and growing. But conceptually is what we have to go after. And the only way we can do that is by putting them in really in situations where they have to organize the number, play with the number, you know, make mistakes, revise, and then try to communicate it. And that's what's difficult.
Yeah, that's great, Fran. Am I muted or no? I'm not.
Nope.
I thought that progression was so helpful, and Anna, that gets exactly to what I'm talking about. That, you know, you've got the whole layout of that development of counting and cardinality, and each one of those elements of the progression becomes a focus for teaching, learning, and formative assessment. And all of the activities that you saw him doing are things that children can be doing, and while you're talking to them, watching them, asking them to explain what they're doing, asking them questions about what they're doing, that becomes formative assessment that you can either react to in the moment, or you can make a plan to do a mini lesson with a whole group or a whole class or whatever, but really being guided by their thinking. I really like that. Is that from the Arizona folks, Jason McCallum and co?
Yeah, well, they wrote the original progressions, which are documents.
Yes, I know.
And so all Graham Fletcher did was add his creativity, his practicalness, and his art, and kind of spelled it out so the stories, and so the progression is understandable.
Yeah.
And they're all that way. He has one for addition and subtraction, one for multiplication, one for division, and one for fractions.
Anna, that would be great to share with your school, and maybe for you to watch the addition and subtraction one as well. I don't know what you thought of that. Let's just, because I'm all excited about this now. So,
yes, I think definitely I'm gonna share it with all my co-workers at school. So
yeah.
actually see and implement that in their classroom.
Yeah, and like I said, you know, you can plan for, and you put it in children's language. You're not going to talk about subitization with little children, but help them understand, you know, what's the point of what I'm trying to do here. And then, and I think you can see the, you know, the value of maybe sitting with 3 or 4 kids and just watching them, how they're counting along these ideas of progression, asking them questions. I mean, that basically is formative assessment, because you're seeing that number sense, that understanding is evolving.
Yes.
So I think those are great. I'm going to use those. I wish I'd known about those. I can't believe I didn't, but that's a great find for me, Fran. Thank you so much.
You are welcome. Plus, he's just a super great guy. I mean, he's a thinker. He's a teacher.
Yeah, I can see that. So have you got those down, Anna? Because those are just fantastic resources.
Yes, I did. Thank you.
Yeah, I'm going to make sure that everybody in the sessions knows about this. Because aside from anything else, they're a great representation of what progressions are.
Mm-hmm.
You know, and exactly what I was trying to say about these stepping stones. You've got them right there. Those are all the stepping stones. And you see how the goals get connected, and the formative assessment's already embedded in the learning activities that you plan to take kids through that progression. So that's super. Great resources. So can we go back to the slides now? Let's just, do you want to just talk about this, Fran? Because you were talking about it, and it all was echoing, and I think it was a little crazy. So.
I wasn't talking about the number lines, because we put this in because this is sort of a middle school model. Dave, you want to talk about it at all, or we don't need to since Anna is kindergarten?
Well, I mean, really the slides just indicate the progression on the use of number line, which I think comes in around 2nd grade and goes all the way through high school. But I'm not sure that it applies in this context.
Mm-hmm. But at least
Anna, you could have some number line work in kindergarten, which is absolutely okay, but you're just sort of, actually I've seen some work where kindergartners do number lines as a sort of a long rectangle, and they have, you know, partitions, units on the number line, and then as kids get older, then we take off the bottom part and just show that it's a linear example of the same thing. So
No, I actually do. I do. They already know what the number line is and how to work with it.
nice.
That's great, Anna. Well, I'm highly recommend, Anna, that you look at that addition and subtraction video progression, because it sounds like, you know, your kids could well be moving toward that if they're not already there. And this is helpful. I mean, I'm learning tons on this. Thank you, Fran and Dave. I'm learning a lot. So this unit of the different sets of numbers. And so this is why they use number lines for fractions as well, not just parts of, you know, not just the whole part concept, right? This
Right.
whole idea of the coherence of a number line. Mm-hmm.
Well, it's a linear model, and certainly fractions show up there as well as in a part whole or something like that. So
Yeah.
we have to look at fractions in a variety of ways.
Mm-hmm. Yeah, who's that guy, Wu? He's obsessed with fractions.
Oh, yes, Wu from Cal. Yes. Is he still at Cal, Dave?
Yeah.
I can't hear Dave.
I missed your question. What was your question?
Wu? Where is Wu?
Oh, he's at Cal. Yeah, he is. Yeah.
Yeah.
This is just a scholar, Anna, who hates this, you know, part whole idea of fractions, that kids always think about fractions as a pizza.
Yeah.
Then they don't ever get the concept of a fraction on a number line as, you know, between the whole numbers. So that's great. Okay, so next slide. I'm all excited now. I don't know where we are. I feel, I mean, if you've not learned anything, then I certainly have today.
Oh, no. I learned a lot.
Yeah, right.
Well, and Paul, you can click through a few other slides. I mean, this is just an example on the progression of number lines. But I think Fran's example is a little more applicable in kinder. But what I will add as you go through here is,
Actually, go back to the other one. Would this be applicable to any of, before the rational, would this be applicable to, is this too abstract for a kinder?
Well, no, it's got fractions on it, so yeah, no. But I mean, if you put whole numbers on it, I mean, I've seen kindergarten teachers, and maybe Anna, you do this too. I did in first grade, where you just put a number line, you hand out Post-it notes with whole numbers on it, and you have kids put the number somewhere on there, and if you want to move someone's number, you can. So if I put a 5 really close to the 1 and another kid has a 3, then they have to ask to move the 5 so they can, and all the time justifying where they're putting, and number line activities like that you can do all the way up to fractions, but with little kids, do numbers.
Stick with the whole numbers.
Mm-hmm.
Yeah.
But again, Anna, I hope you're seeing how with the representation and the explanations and with questions and prompts from the teacher, how that becomes formative assessment of this deeper understanding that we're trying to get to in mathematics. So it's not about, you know, giving them a test or giving them an assessment, but it's doing what you're doing, making time and being very intentional about what you're looking for vis-a-vis the learning goal and the success criteria. And then your interpretations of what they're doing and what they're saying is telling you about their understanding. So all of these representations are really important sources. And of course, that's a big deal in mathematics and the Common Core, use of representations.
Yes.
Yeah, anything to add, Dave, to all of this? I know you were going to go on a bit further. Dave?
oh, I mean, I think Fran's example was a little more practical for kinder, but one of the things that I loved is, as Graham Fletcher was talking about composition and decomposition, that if we talk about those stepping stones, I mean, that brings us all the way forward to algebra and to factoring. And, you know, so many of those foundational pieces are critically important that students understand the concept of those for when kids reach higher mathematics, that they understand that concept, because factoring can't just, again, be this procedural piece. They have to understand the concept of composition and decomposition, which starts in kinder.
Yeah. So you see, Anna, how you're setting the foundation for later mathematics. I know I worked with some kindergarten teachers once, and once they recognized that and realized that, they were so excited. You mean I'm laying the foundations for this? And I said, yeah, you sure are. And then that's what I put in, because it's something we talked about in the session, and it goes back to this whole idea of the conceptual understanding, because you want kids to be able to use their mathematics in novel situations. So, you know, this idea of transfer and generalization, generalizability, that's big across all domains. So they're not just learning this discrete little skill that works in this particular situation, but they're able to think mathematically and use their concepts in problem solving across the board. I don't know if you have an example, Fran, for kinder, how that might, you know, think about transference, what we want kids to be able to transfer to new mathematical situations.
In the addition, subtraction, progression, Graham Fletcher talks a lot about the use of 5 frames. So when students see that 5 is made up of, you know, 2 and 3 and 1 and 4, then all of a sudden they can start to transfer this idea to, oh, I can see if I make a 5, if I'm doing something like 4 plus 3, I can make a 5, and 4 plus 3 is the same as 5 plus 2. So there's all these kind of building blocks that go on where they kind of, I mean, they arrive at that understanding because the foundations are so strong. It's really exciting to watch.
Yeah, they just sort of go, don't they?
Yeah.
Foundations there. It just becomes, oh, yeah, I know how to do this. That's a great example. Yeah. So, you know, back to that that screen I had, Anna, with all the dots about this atomistic learning, that doesn't lead to transfer. So the kind of mathematics we've been talking about here for planning and for formative assessment really grounds this notion of transfer and generalizability, because that's what we're going for. So next slide then. Let's just pause and then see if there are questions and comments. Graham, Fran, Anna, Paul, questions, comments?
No.
I can't believe nobody has one question. But if you don't, I mean, Fran and Dave, does what I'm saying make sense to you?
Yes. Yes.
Yes, absolutely.
That we want these rich, productive learning experiences that build a mathematical thinking that can really lead to procedural fluency, but also become occasions of formative assessment. Because as I kept saying in the session, Anna, it's not about, you know, developing an assessment or putting an assessment together, because it's right there. If you've got rich instructional tasks and you're having conversations and prompting kids for explanation, you really do get that insight into their thinking, which is what we want here. Okay, so in the absence of questions, let's move on. So this just reminds you of what makes a good learning goal that we said in this session. So first of all, it's clear and linked to the bigger picture of learning. And, you know, whilst it might not be, and certainly it needs to be linked to prior knowledge, prior understanding. And I think what was nice in the sessions, and I think Downey was the same as the others, that everybody talked about, well, if I'm doing this learning goal, it means they've already learned this. So it was connected, but also to that bigger picture, like where's this headed? Where's this going to? If I'm doing this today, what's the picture for all of us? And then the next one is focused on the learning. What are my kids going to learn? Not what they're going to do. And like I said in the session, so many teachers, when I ask what they're learning, they tell me what they're doing. And I say, well, I can see that, why they're doing it. So really focus on that learning. And that's why the progressions are so helpful, because you get down to those fundamental aspects of what's the mathematical learning that we want kids to be engaged in. And then the next. And written and communicated from the student's perspective. So kids need to know at some point in the lesson what it is they're learning, and obviously it needs to be communicated to them in a way that they will understand. So they really need to understand this. They really need to be able to internalize it, and it's time limited. And I generally say one lesson, 1, 2, 3 class periods or sessions, activity sessions with your Ks. And then the final one here is that we want these goals to lead to these rich, productive learning experiences, which also provide occasions for formative assessment. So from that perspective, and then let's go to the next one, because we talk about success criteria. How do we know that the kids are learning what we want them to learn? So these are the indicators, what tells us. So if they're going to tell us about the learning goal, they've got to be linked to the learning goal. These have got to be indicators. If you think back to, the counting, what are the indicators that will tell you that the kids are moving forward to understanding the concept of cardinality? What will they say? What will they do? The next one is, continue to focus on the learning, keep the performances of learning. What are those learning, as with any assessment, you need the performance of learning. And so this focuses on the learning and illustrates what's expected. How will I know as a teacher, and how will the kids know? And, from my experience of working with Ks, they can certainly begin to think about, are they learning what they're supposed to be learning? They can certainly do that. And then, again, from the kids' perspective, and then finally, the productive learning experiences. Actually, Anna, and the rest of you may not know, but that's how I began my career as a kindergarten teacher. Mm-hmm. Yep, that was me, right in the beginning, a K teacher. And I don't know how you do it, Anna.
A lot of patience.
A lot of patience. Yeah, patience. But a lot of energy. A lot of energy. So here we have the learning goals and success criteria. And what I was going to do now for the latter part of the webinar was to really look at some goals and criteria. But maybe we can have Fran and Dave comment on the ones that, this was from a first grade teacher. So thinking about the criteria, Anna, do you want to, I'll give you a minute to read it, and then do you want to take a stab and let us know if you think this is strong or weak, somewhere in between, how could it be improved? So let's just read it, and then maybe Anna can jump in, and then we'll have Fran and Dave. This is the first grade. So I know we don't have the criteria up, but what do you think, Hannah?
I think for kindergarten is asking for a lot of steps within the problem. I think what I need to do is target one step at a time, because I think the objectives are too many in one problem.
This was a first grader. They were solving a one-step word problem towards the end of first grade, and that's what they've been working on. Yeah, this is way too much for Ks.
But I think definitely, I mean, they can definitely do it.
So something they do a lot in this class is explain what the word problem is asking them to do. So they get a sense of that, and then the strategy and explain their thinking. Fran, Dave, what would you say about this?
The only thing I would add to this is the idea of modeling, some kind of model. So the strategy could support a model that they draw, a model that they build, but some way to show their process and their thinking.
Other than the explanation, they actually do some kind of representation.
Yeah.
Nice.
Yeah. And sometimes that's where kindergartners can start.
Yeah.
Draw a picture and add labels or numbers to it, and then use that to explain their thinking.
Well, I have nothing else to add to that. I think pictorial representation is certainly very valuable. The only piece that I think I would add is that oftentimes a student's pictorial representation really is a way for them to demonstrate their understanding of concept.
Yeah.
If we're moving toward really doing formative assessment on a student's conceptual understanding, sometimes the way we gain information on that is by hearing their discussion, but another way that we gain information on that is by looking at the pictures they can draw.
Right.
So I just have a question for Anna. I want to make sure you're okay for time.
Oh no, I'm okay.
Okay.
Yeah, we'll close out fairly soon, and certainly we appreciate your sticking with us for the ride, Anna. But that's good information from Fran and Dave about the pictorial representation, some kind of model. And I certainly think from the point of view of formative assessment, that's a great opportunity right there, already built into the lesson. And then when you ask them to talk about it, you can really get some insights. I mean, one of the things that we haven't talked about, which we'll be talking about in the next face-to-face session, is what you do with that evidence, what the talking and the looking really yields in terms of information, and then how do you act on that. That's for part 2. So probably some of these are, let's just go to the next one. That's probably, well, it's certainly beyond
Yeah.
So just to get a reaction from Fran and and this is 8 or 9. So let's not do that one because that's really some people in Iowa did that. Now, I was going to go back, Paul, to the one that we had before, just to get Fran and Dave's reaction to this.
We were wondering if that was on the second bullet under criteria, if that should say 0 to 1, a number line 0 to 1, not 0 to 12.
Oh, yes, it should.
Yeah. Well, that's what we're figuring because you're only using one of the units. But
Yes,
I mean, this is kind of what we were talking about with sticky notes. You could do this whole class and then maybe individually after to see what kids understand. But the idea that I could put a big line 0 to 20 on the board and give kids whole numbers and just say, put your number on. You know, if there's a number line, let's try this. So same idea with unit fractions.
Yeah. And again, another great formative assessment opportunity right there when you see where they put them. And then if you have kids, respond to, well, why did you put them there? Explain why you put them. Yeah, great. I think I want Fran and Dave at all my sessions, Paul. You just please make that. It's so helpful having subject matter people. It's just I mean, I know stuff, but I just don't have I'm not even close to your depth of knowledge. So hasn't it been fun having the subject matter folks, Anna? I think
Yes,
it's terrific.
definitely.
Yeah. So next one.
Can I just add in one more thought to that? The other piece, along with formative assessments, if we think of Fran's Post-it notes or sticky dots, is hearing students' conversations when they go up to the line and having them interact with each other. That, you know, mine is 5, but I'm going to move yours over a little bit so that I can have some space to put my 3 or 4. Is another valuable piece of formative assessment.
Absolutely. These are great. We won't do this one because we don't have any middle school people. So, Anna, here we are at the end. You've certainly been a trooper, and
No, I mean, thank you very much for providing these webinars. I think this is really important for us as teachers to be able to have, you know, new ideas so we can, you know, help our students succeed.
And yes, absolutely. And you will have access to this. So you've got the progressions to share with your colleagues. And also, you know, if you wanted to, I don't know how Paul's going to disseminate the audio, but certainly I think it would be useful to have. And Paul, if we could let other folks know, I know it was pretty short notice getting them and after a holiday weekend. So Anna, you get triple brownie points for this. You really
Thank you.
and Fran and Dave. So just flick through the last few slides and then we'll let Anna go to, let's just finish with this. Another I used to, but now I used to think that formative assessment was purely a form of assessing students at the end of the lesson. Now I see it as an overarching way of designing lessons so that the goals are made very explicit. Students are asked to explain where they are with their understanding, and that teacher feedback is an essential tool guiding student learning. Well, we haven't talked about teacher feedback yet, but we will. But it's impossible to give feedback if you don't have the goals, you don't have the criteria, and you don't have the evidence.